Okay, so let's close out this lesson by looking at a couple of special cases, a couple of things we want to be able to do quickly, sort of keep them in our back pocket for the time when we need them. One of the things I want to deal with are complementary events. Complementary events are opposites. They are events where if one happens, the other can't happen. And the best case scenario to think about this, if we look outside our window and the weatherman says that the probability of rain today is 0.3, the way he would say that is to colloquially argue that there's a 30% chance of rain. So if we convert that to a fraction between 0 and 1, because probabilities are fractions between 0 and 1, if we say the probability of rain is 0.3, then we say that the probability that it will not rain is, well, you would say that, right? Because you would say that all probabilities add up to 1, but there's a 0.3 probability that it rains, and that leaves a 0.7 probability that it does not rain. What makes these events complementary? If this one happens, that one can't, and vice versa. If it rains, then not rain doesn't happen. If it doesn't rain, then by definition, rain doesn't happen. These are complementary events. Complementary events, so if we imagine the universe as some big rectangle, oftentimes we'll see events described in Venn diagrams. So we'll say roll a 5 on a die and flip a head on a coin. They could come together. They might not come together. There's a chance you don't get either at all, right? But with complementary events, there are no circles at all. This is rain, and this is not rain. They can't come together. There's no way that it can be this and also that. These are complementary events, and one of them has to happen. So it's not just that if this one happens, that one doesn't, and if this one happens, that one doesn't. It's that it is not possible for both of them to happen, and it must be that one of them happens. It's either going to do this or that. And because of that, whatever this probability is, this probability is 1 minus p. Because all of the probabilities for a particular event together add up to 1, because 1 represents 100% of the time, and that's what we've got going on here. The other sort of scenario that I want to take a look at is what happens when we talk about mutually exclusive events. Complementary events are mutually exclusive. Mutually exclusive events have no intersection. So complementary events are a special case of mutually exclusive events. In mutually exclusive events, if the one happens, the other does not happen. Those circles never cross. But it isn't necessarily true that one of them has to happen. So what's an example of this? Well, we might take a look at someone who has blonde hair, and then we might take a look at a brunette over here. If you're blonde, you're not brunette. If you're brunette, you're not blonde. But then you got a redhead out here going, hey, what about me? I'm not blonde, I'm not brunette. And then you got somebody with black hair out here going, wait a minute, I'm not blonde, I'm not brunette. So while these events are mutually exclusive, it's not, well, I don't think it's possible. I suppose I'm going to find out in the comments that it might be. But in my limited experience, if you're blonde, you're not brunette, and if you're brunette, you're not blonde. But it is not the case that these two fill up the universe, because we have other possible colors of hair. And I do recognize that just because a person has red hair does not make the entire person red. I recognize that. And so that's the way that goes. So these are mutually exclusive events. Mutually exclusive events, to use the language of set theory, the probability of blonde intersect with brunette is 0. There is no probability, there is a 0 probability that those two things happen in the same case. So those are a couple of things that your authors wanted to point out to you, and so I wanted to point them out to you, and I hope that they are clear to you and that they give you some understanding as you tackle some of the questions in this section. See you soon.